Bismillah ar-Rahman ar-Rahim. Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh. Hello dear students, I hope you're all doing well. Welcome to another video from our channel Easy Chemistry for All. This is Mr. Muad, and inshallah we'll begin a new lesson today. Before we continue, thank you guys for your subscriptions. We reached 339 subscribers as of now. Again, please try to share the channel with your friends all across the country, and if you didn't subscribe, please subscribe so that our channel can grow and hopefully many more students can benefit from the videos, guys. Okay, so thank you very much. All right, so now we start in module 15. Okay, last time we finished module 14 lesson 5. Today we start in module 14 lesson 1, and it's called a model for reaction rates. So we'll talk about chemical reactions, and when I say the word rates, guys, I mean speed, okay, or change over time. Okay, so for example, speed is the change of distance over time, right? Now we are going to see what rate means in chemistry, but usually it's like the speed of the reaction. Okay, so we are going to calculate, or you will be able to calculate the average rates. Okay, so when you see average rate, I will call it AR. Okay, average, from A from average and R from rate, okay, of chemical reactions from experimental data. And then we will relate rates of chemical reactions to collisions, تصادمات, between reacting particles, ما بين الجسيمات المتفاعلة. Okay, so these are the main learning objectives of the lesson. So we'll start with part 1. We will define what we mean by reaction rates, and then we will calculate the average rates of chemical reactions from experimental data. Okay, so how can you tell if a reaction is fast or slow? Okay, so the main idea of the lesson is that collision theory, نظرية التصادم, is the key to understanding why some reactions are faster than the others. So the collision theory will tell you why, or explain why some reactions are slow and why some reactions are fast. Okay, we'll see that in part 2. So as I told you, these are the keywords. Reaction rate means reaction speed. Collision theory, activated complex, activation energy, we will see in part 2. So reaction rates or reaction speeds, guys, are determined experimentally, يعني تجريبيا. Okay, في المختبر. Okay, in the laboratory. Okay, عن طريق التجارب. Okay, this figure shows you a reaction, how a reaction proceeds from reactants to products over time. So imagine this is my reaction, guys. Okay, this is the reactant and this is the product, صح؟ هذا المتفاعلات وهي النواتج. So at time 0, before anything happened, I only have reactants, right? As you can see here, nothing happened yet. Now with time, the reactants are going to go down and the products will go up. لأن المتفاعلات قاعدة تتحول إلى نواتج، صح؟ So you will see some blue pyramids here. With more time, there is less red boxes and more blue pyramids, the products. Okay, as you keep going, the reactants go down and the products go up. كل ما التفاعل أو الوقت يمر، المتفاعلات بالأحمر تقل والproducts اللي هي النواتج تزيد. This is true for chemical reactions or basic chemical reactions, irreversible chemical reactions. Okay, so the reaction rate, okay, the reaction will always proceed from reactants to products, guys. Okay, over time, and the reactant size or the reactant's quantity is going to decrease and the product is going to increase, as we saw in the previous slide. Okay, and this is the equation which we calculate the average rate. It's delta quantity over delta t. Quantity يعني الكمية، كمية المتفاعلات أو كمية النواتج. Delta t is time. So you know that delta is always final minus initial, right? So that's the meaning of the word delta. It explains the change in quantity. And this is the equation for the average rate, guys. Average rate equals delta quantity over delta T. Now the reaction rate, okay, of a chemical reaction is the change in concentration, التركيز, okay, of a reactant or product per unit of time. التغير في تركيز المتفاعل أو تركيز الناتج مع الوقت. It's expressed in mole liter per second, mole over liter times second. Okay, the brackets around the reactant in the equation represents the molar concentration. So, what do I mean by this? So, the average rate is equal to delta change in concentration over delta T. This thing here represents concentration in molarity, اللي هو المولر concentration. شو معنى المولر concentration؟ يعني هاي الكمية وحدتها مول over liter or capital M. Remember that molarity is equal to moles over volume in liters. So moles of solute over volume of the solution in liters. يعني يقول لك كم كمية المولات الموجودة في اللتر من المحلول. فإحنا هاي الكمية اللي فوق دائما نكتبها بوحدة المول per liter وتكون معناها التركيز or molar concentrations. We don't use grams, we don't use moles, we use mole per liter. So this one is mole over liter and the time is seconds. So if I do moles over liter over second, that's going to give me mole over liter times second. هذه وحدة قياس الافريج ريت اللي هي مكتوبة هنا. Okay guys? So, which is not true of the reaction rate of a chemical reaction? So stop the video, try to answer and then come back. Not true, guys, okay? So it's the change of concentration or in concentration of reactants or products over time. This is true. It's determined experimentally, yes. It's expressed in mole per liter over liter per times second, yes. It can be calculated from a balanced equation. No. It is determined experimentally من التجارب مش من خلال المعادلة. So our answer is this because they are telling you what is not true. Right, guys? Now, how can we express the reaction rate from actual chemical equations? So imagine this is a chemical reaction, right? So this side reactants المتفاعلات and this side products. So this one using products. هنستخدم البرودكتس عشان نحسب الافريج ريت، ما راح نستخدم الرياكتنتس، okay? And we'll focus on NO. So they tell you if the concentration of NO is 0 molar, as I told you, M is actually mole over liter, اللي هي المولاريتي. At time 1, 0 seconds, okay? And it became 0.01 molar 2 seconds after the reaction begins. Calculate the average rate of the reaction. So you have time 1 equals 0. You have the concentration of NO at time 1 equals 0 molar, 0 second. And then time 2 equals 2 seconds. طبعا الاس للسكندز. Well, concentration of NO at time 2 equals 0.01 molar. So this is what they told me. And they said calculate the average rate. So the average reaction rate, or the AR, is going to be the concentration final minus initial over time final minus time initial. Or we can represent it like this. So remember the delta, change in concentration, and this one, the brackets قلنا هي تعني المول per liter. So just put the numbers, guys. You already have them here, right? So it's going to be 0.01 minus 0, because this is final and this is initial, over 2 minus 0, and this is the answer. 0.005 mole per liter times second. What does this mean? What does it mean? شو معنى هذا الرقم؟ It means the reaction، هذا التفاعل اللي فوق produces، قاعد يكون 0.005 mole over liter of NO nitrogen monoxide every 1 second. يعني سرعة هذا التفاعل قاعد يكون لي 0.05 مول per liter of NO اللي هو nitrogen monoxide هذا اللي هني كل ثانية واحدة. Okay? So this is just to tell you, remember when I told you that M equals mole per liter? So this whole thing here, mole per liter, is M, and that's why they wrote it here, okay? So M over S is equal to mole over liter times S. في الامتحان إذا كان في امتحان أو شيء هذا الاثنين معناهم نفس الشيء. Okay? So they mean the same thing. Okay, now if we use reactants، إذا استخدمنا المتفاعلات، okay? What will happen if we use reactants guys؟ So الحين هذيك في الصفحة اللي طافت استخدمنا البرودكت، الحين بنستخدم الرياكتنت. So you can also choose the state or choose to state the rate of reaction as the rate at which CO is consumed. يعني نستخدم CO في حساب average rate. Okay? So guys, what happens to CO؟ CO اللي هو متفاعل شو لازم يحصل له مع الوقت؟ يعني imagine at time 1 which is 0 seconds the concentration of CO is equal, for example, 1 mole over liter. At time 2 which is 2 seconds the concentration of CO، هل الكونسنتريشن الجديد أو الكمية الجديدة لازم تكون أكبر من 1 ولا أقل من 1؟ والCO هذا متفاعل يعني أنا قاعد أستخدمه يعني قاعد ينقص. So because it's decreasing, it's a reactant, the concentration should be lower than 1. So for example, let's say 0.5 mole per liter, right? So if we try to calculate the average rate, it's going to be final minus initial, so 0.5 minus 1 over time final minus time initial, which is 0.5 over 2, which is 0.25 mole over liter times second. But there is a problem here. 0.5 minus 1 المفروض الإجابة بالناقص, so this is minus, right? And this one should be minus. So can I have something like this? This is wrong. I cannot have an average rate in the minus, guys. Okay? This is only for reactants لما استخدم المتفاعلات. That's why when we use reactants we should modify this equation. How? We are going to add minus here. Okay? Only when I use a reactant. So this is the average reaction. So this is the average reaction rate when I use reactant. If I use a product like here, I don't need the minus because NO is a product. Okay? So we use it only the minus sign. الإشارة السالبة هني في القانون نستخدمها فقط إذا السؤال أعطانا كميات المتفاعل وقالنا احسبوا الأفريج rate. Okay, so we don't use it for products. And this is the equation that we saw so far. Okay, guys? So let's solve this example together. In a reaction between butyl chloride and water, so reaction between يعني تفاعل ما بين this and water. So C4H9Cl and water، طبعا احنا نعرف انه الووتر رمزه H2O. هل حيكونوا متفاعلات او نواتج؟ يقول لك تفاعل ما بين هذين الاثنين. يعني هم لسه حيتفاعلوا مع بعض. So these are reactants. متفاعلات. Okay guys? The concentration of C4H9Cl is 0.22 molar at the beginning of the reaction. So when you see the beginning of reaction, it means T1 equals 0 seconds, because this is the beginning, before anything. At 4 seconds, this is time 2, the concentration of C4H9Cl is 0.1. يعني الكونسنتريشن نقص، يعني هذا متفاعل، حتى لو ما عرفناها من البداية، ما دام انه نقص فالمفروض يكون متفاعل. Calculate the average rate over the time period expressed as mole consumed per liter per second, اللي هي mole over liter times second. So this is what we have, guys. Time 1, initial, final. Concentration at time 1 was 0.22, and the concentration at T, the final concentration was 0.1. So write the equation. Average rate equals minus delta C4H9Cl over delta T. Why did I use minus here, guys? ليش استخدمت الناقص هني؟ Because it's a reactant, لأن هذا متفاعل, and we saw it here. Okay? So it's going to be equal to, I'll put the minus outside, final minus initial. So 0.1 molar minus 0.22 molar over final minus time initial in seconds. So it's going to be equal to don't forget the minus, so it's going to be 0.03 m per second, which is equal to 0.03 mole over liter times second. Okay, guys? So this is your answer. It means that 0.03 mole over liter of this one is consumed every 1 second. يعني احنا قاعدين نستخدم 0.03 مول على اللتر كل ثانية واحدة قاعد تنقص. Okay? So this is the answer. You can have a look at the book's explanation here. Stop the video and have a look at it if you want to study the problem again. Okay? Okay, guys. These are problems which you can solve. Okay? You have the reaction here. Okay? You have the concentration. Okay, this is initial. This is final time. This is the concentration of H2, initial and final. For Cl2, initial and final. And for HCl, only initial. So you can use the table to solve questions 1, 2, and 3. So practice on your own, and then you can check your solutions here. الإجابات موجودة. Okay? Also here. Alright. That's the end of part 1, guys. Okay? So now we go to part 2, which talks mainly about the collision theory, نظرية التصادم. Okay? So we'll describe the collision theory, relate rates of chemical reactions to collisions between reacting particles. Okay? And compare between reaction spontaneity and reaction rates. Okay? So, we are going to start with the collision theory, guys. Okay? But before we do that, let's just have a look at these figures. Okay? Now, imagine you are pushing. My drawing is very bad, guys. Imagine that you are pushing this box, okay? Same weight. Let's say it's like 10 kilograms, and this one is also 10 kilograms. Which one is going to reach to the top first? Box A or box B? So, of course, as most of you will say, it's box A. Why? شو السبب? Because the distance in A is smaller than the distance in B, right? That's why this is faster and this is slower. Now keep this image in your mind. خلوا هاي الصورة عندكم. If this distance is small, the box will reach faster. If this distance is high, the box will reach slower. Okay? You will see when we are going to use it. So, how can we tell if a reaction is fast or slow? By using the collision theory. What is the collision theory, guys? نظرية التصادم. Collision theory states that atoms, ions, and molecules must collide in order to react. يعني مثلا imagine that I have A2 here and this is B2 اللي هم المتفاعلات. عشان انه يحصل تفاعل لازم يحصل تصادم ما بين هاي الجزيئات between these molecules, okay? So they should collide, تصادم. And then they will create the product, okay? So this is AB and this is AB. That's why we have 2AB here. تمام؟ هذه نظرية التصادم. Very easy, right? But do you think all collisions are going to produce products? هل كل التصادمات بتكون لي أو نواتج؟ No. So when reactants collide, they form an activated complex, which is a temporary unstable arrangement of atoms. لما يحصل تصادم الجزيئات تكون لي شيء اسمه activated complex. Okay? This is an unstable arrangement مؤقت. شو يحصل في هذا activated complex? Old chemical bonds are breaking. الروابط الكيميائية القديمة قاعدة تتدمر. And new chemical bonds are forming. So this is in reactants. And this is for products. لأن الروابط الجديدة اللي تتكون حق البرودكتس النواتج. So you have the reactants, right? They will collide بيحصل تصادم وبعدين بيكونوا لي شيء مؤقت. هذا مؤقت. It's called the activated complex. What happens in here? This is what happens. Old chemical bonds break and new chemical bonds are forming. And after that, the products will be produced. Okay? So the activated complex, this thing here, is a structure between reactants and products. يعني هو يكون ما بين المتفاعلات ويكون ما بين النواتج. If the collision is correct, إذا التصادم يكون صحيح, the activated complex بيكون products. This is if you have correct collision. الحين بنشرح شو معنى correct collision, okay? If the collision is incorrect, it will rebound, go back to reactants. So incorrect collision. إذا كان التصادم غير صحيح فالactivated complex هذا راح يرد ويرجع للمتفاعلات ما راح يكون نواتج. Okay? So what do we mean by correct collision? So the activated complex is a combination of collision orientation اللي هو اتجاه التصادم and the energy of the collision طاقة التصادم. It determines if a collision will result in a reaction occurring or not. يعني this is going, these two things, the energy of the collision and the orientation of the collision are going to tell you if the reaction is going to happen or not. Okay? So for example, these are the reactants, right? Look at this red part and this red part. They are going to collide together, بيتصادمون. لكن الاتجاه هذا اتجاه خاطئ. So this is incorrect orientation, so no reaction. Okay? Again here, the red with the blue are going to collide. Again, no reaction. ليش؟ لأن الاتجاه خطأ. Now, if the red from here and the carbon or gray from here collide, this is correct orientation. اتجاه صحيح. So they are going to form activated complex, and then the activated complex will form products. Now here, energy is sufficient. الطاقة كافية. طاقة التصادم كافية. الحين لو كان الاتجاه صحيح, so correct orientation, لكن الطاقة غير كافية, no reaction. Okay? هذه نظرية التصادم. The collision theory tells you that reactants need to collide. لازم يحصل فيه تصادم. هذا أول شيء. ثاني شيء لازم التصادم يكون في الاتجاه الصحيح. ثالث شيء لازم التصادم تكون طاقته كافية. So for a reaction to happen, reactants must collide and the collision should be in the correct orientation and the energy should be sufficient. And this is just a summary of what we saw. هذه ممكن تقرأوها بروحكم. فيها ملخص كل اللي ذكرناه قبل شوي. So now try to quiz yourself. Stop the video and answer the question. Which is not part of collision theory. So reacting substance must collide with the correct orientation. هذه part هو يقول لك not part. Reacting substance must collide. This is a part. Reacting substance must collide with sufficient energy. طاقة كافية. This is a part. So the only one that is not a part is this one. Okay. So guys, we talked about sufficient energy. Sufficient energy, right? So what does it mean? شو معنى الطاقة كافية? What's the minimum amount of energy required by reactants to reach the activated complex? Okay, what's the amount required? So it's called the activation energy. So the minimum أقل كمية من الطاقة, the minimum amount of energy that the reacting particles must have, اللي المتفاعلات لازم تكون عندها to form the activated complex عشان يحصل تصادم صحيح وتكون لنا activated complex and lead to a reaction عشان يحدث تفاعل is called the activation energy, EA. Okay, so E is from energy and A is from activation. So what does it mean if a reaction needs high activation energy? إذا التفاعل يحتاج high activation energy or فيه high activation energy, then few collisions have the required energy to produce the activated complex. يعني فقط قليل من التصادمات اللي هي الصحيحة حتحدث. And the reaction speed is slow. So guys, if you have many collisions or many correct collisions equals fast reaction. If you have few correct collisions, إذا في تصادمات شوي بس, it's a slow reaction. فهو أنت لما يكون عندك activation energy EA very high, it means you need a lot of energy to make a correct collision. So only few collisions are going to happen. That's why the reaction speed is low. Now, if you need low activation energy, more collisions that have the EA are going to happen. يعني تصادمات كثيرة عندها طاقة كافية, لأنه الطاقة اللي تحتاجها المتفاعلات صغيرة, فكثير من التصادمات راح تحدث. And that leads to a fast rate or a fast reaction. Okay? So, high activation energy, slow reaction. Low activation energy, fast reaction. So try to quiz yourself here. What is true of high activation energy? اللي هي EA. Sorry, what is true of high activation energy? شو الصح لما يكون الرياكشن أو الactivation energy وايد مرتفع? We said if you have high activation energy, the reaction is slow. Okay, the reaction rate is fast, low activation energy. Okay, and now we can see the activation energy in the energy of reaction, which we saw in module 14. Remember exothermic reactions, delta H less than 0, negative. So in exothermic reactions, molecules collide with enough energy to overcome the activation energy barrier, and products are lower energy. Okay, or are at a lower energy. Okay. يعني عندنا الجراف, دائما الجراف يبدأ من اليسار إلى اليمين, ودائما اليسار يكونوا reactants. So the graph always starts from the left to the right, and you always have reactants there. Okay. So you start with the reactants, and then you need to go up here. So this point, guys, the top point is where the activated complex is being formed. And the difference between the activated complex and the reactants is the activation energy. Activation energy is the energy of reactants or energy of the activated complex, بسميه ال AC, minus the energy of the reactants. يعني الجراف النقطة ما بين الانرجي ما بين الاكتيفيتد كومبلكس والمتفاعلات هي الاكتيفيشن انرجي، وما بين المتفاعلات والنواتج it's the delta H, remember that we talked about in module 14. Okay, so this is for exothermic reaction. Now we can go to the endothermic reaction اللي هي الدلتا H فيه تكون the delta H is positive. Okay, so because the products have higher energy than the reactants, remember? So the activation energy here, this is all the activation energy لأن هي الطاقة ما بين الactivated complex والمتفاعلات reactants. Okay guys? So try to answer this question, stop the video and then come back and try to answer this question. Okay guys, so what did we say? This is the activation energy, right? Between the activated complex or reactants. We said low EA equals fast. High EA equals slow. So which one should be faster here? Of course it's going to be A, guys, right? So this one is going to be faster. Why? Because it needs only a small amount of energy. Remember the box at the beginning of this part? The box example. قلتوا مين حيوصل للتوب أسرع؟ كان عندنا صورة A وصورة B. مين اللي حيوصل للتوب أسرع؟ قلتوا A. ليش؟ لأنه الديستنس هني أصغر، صح؟ So because it has a low EA, it's going to be fast. And here قلتوا إنه المسافة طويلة, the distance is high. That's why it's going to be slower. And that's why reaction B is slower than reaction A. Okay? Now we reach the last part, okay, which is called or relates spontaneity with reaction rate. Remember, I told you, if we talk about spontaneity, we talk about delta G, Gibbs free energy, اللي تكلمنا عليها in module 14. So, spontaneous or non-spontaneous is related to delta G, free energy. If delta G is negative, قلنا إنه reaction is spontaneous. If delta G is positive, delta G أكبر من صفر, the reaction is not spontaneous or non-spontaneous. Now, delta G does not affect the rate of chemical reaction. No relationship between delta G and reaction speed or rate. Okay, it does not affect the rate of the reaction. يعني delta G فقط نستخدمها في spontaneous أو non-spontaneous. ما نستخدمها في speed of the reaction. Okay. So which of the following is not true? Stop the video and come back. Of course, it's going to be this one. لأنه delta G, if the delta G is negative, the reaction is spontaneous. فهي خطأ. Because they ask about not true. Now, when we talk about reaction spontaneity, it depends on delta G. لما نتكلم على reaction speed أو rate, على شو تعتمد؟ على أي طاقة؟ Depends on the activation energy, the EA, okay, which we talked about in the previous slides. Very important إن إحنا نفرق ما بين هالاثنين. Alright guys, that's the end of module 15 lesson 1. Thank you for watching the video. Again, if you have any questions, you can contact me or you can leave a comment on YouTube. Please again share the channel with your friends and subscribe if you didn't do so. Okay guys, wish you the best and see you in the next video. All the best guys.